Okay, good afternoon class. Okay, so today we're looking at the paper you guys wrote last year, which is the grade 11 November 2021 paper 1. At this point we have completed paper 2 and it's online if needed. Okay, so let's get straight into it. So it's a 3-hour paper for 150 marks. Alright, so anyway, in the video we look for this, for that, what's his name, and then you'll know exactly which paper you're on or where the work is coming from or whatever. Okay, in any of the videos, just look for that. Alright, that's it, let's go. In question 1.1, the question says solve for x. It says solve for x. So from here, what we need to do is, since we have the question already factorized and equal to 0. So what can we do here? We set each factor equal to 0. The 0 factor rule. So we got 5x minus 2 is equal to 0. Or 4 and 7 over 8 plus 3x is equal to 0. You take the 2 over, becomes positive 2 divided by 5, so x equal to 2 over 5. Or we take that over, it becomes negative, so it's 3x equal to negative 4 and 7 over 8. Divided by 3 both sides. So x is equal to 4 and 7 over 8. Divided by 3, and they give you 13 over 8 in the negative. Okay. Any confusion? Yes? Sorry? You've multiplied it out. Then you add your like terms, then you substitute the quadratic formula, not so. Then you'll get 2 over x equal to 2 over 5 and negative 13 over 8 as well. Okay, so you're going to land up with exactly the same thing. The something you must note at this point is, for the 0 factor rule, once it's already factorized and equal to 0, from there it's just a matter of wrapping it up. So each factor equal to 0. However, if that had to be a number, then I must multiply it. Bring the number over and then add like terms and refactorize or use quadratic formula. Okay. The next one, which is 1.1.2. One of two ways we can do it. So firstly, this can be written as the cube root of x to the negative 2 equals 4. To get rid of the cube root, I'm going to cube both sides. So you got x to the negative 2 is equal to 64. Now, x to the minus 2 is 1 over x squared. Not so. We cross multiply, we get 1 over 64 is then equal to x squared. To get rid of the square, I square root both sides. So it goes plus minus. So x equal to plus minus 1 over 8. Okay. Whenever you're introducing an even root, then you must not forget plus minus. On the other hand, we could have said, okay, if you got x to the negative 2 over 3, can be written as 2 squared. So to get rid of this exponent, I raise it to its reciprocal, which is negative 3 over 2 both sides. So what happens? That cancels. So I have now x is equal to 2. 2 times negative 3 over 2 is negative 3. But remember, there's a rule that says if the exponent is even, then you must go plus minus when you raise it to its reciprocal. If the denominator is even, the rule says that you must be positive on the right hand side. Okay? So from there it will simply be x is equal to plus minus 1 over. Okay. The next one. We have 14x squared minus 3x minus 8 is equal to 0. From here I can see already the factors are going to be a bit dodgy. So what do I use? The quadratic formula. So x equal to minus b plus minus the square root of b squared minus 4ac over 2a. People, 2a. There's one point in this exam where they give you a mark for substituting into the formula correctly. And this is that point. Okay? Further than this, we don't have to show the substitution into the quadratic formula. This is the only point that needs to be shown. Even if you get your answer correct, out of 3 they only give you probably 1 or 2. Okay, they will penalize you there always. So you got x is equal to, as you know, the a value is the coefficient of x squared, which is 14. Your b value, of course, is negative 3, and c is negative 8. So you got negative 3, which is 3 plus minus the square root of. Negative squared is always positive, so it's going to be 3 squared minus 4. A is 14 and c is negative 8, all over 2a. If you're going to put a negative there, just make sure you're putting that in the bracket. Okay? So what learners do is they write it down, but they don't put the negative 3 in the bracket. So you got 3 plus the square root of negative 3 squared minus 4 times 14 times negative 8 over 2a, which is 2 times 14. That gives me a surd, which is 0,87. So 0,87, or x is equal to negative 0,66. Okay, and we can test if you are correct. Okay, so since the answer, the present answer is the last answer calculated here, which is negative 0,66. You say this 14 squared. 14 squared minus 3 answer minus 8 should give an answer of 0. Okay, so yes, it works. The next one, let's pull this out here. As you can see for the next one here, you got 3 to the x plus 2 plus 3 to the x equal to 270. So this is an exponential equation. So what we do is we break up so that we can factorize. So it's 3 to the x times 3 squared plus 3 to the x is equal to 270. So you ask yourselves, okay, what is common here? 3 to the x. Not so. What are we left with? 3 squared plus 1 equals 270. Okay, and what is 3 squared? 9 plus 1? 10. So this works out to be 10 here. So I divide both sides by 10. So 3 to the x is equal to 27. 27 of course can be written as 3 cubed. Therefore x is equal to 3. Okay. Are these guys celebrities and stuff?
They are.
Sorry?
They are
Rappers. Okay. So yeah, people one of two things, I can use it as it is, or I can introduce a variable to make it a bit simpler. So what I do is I say let the square root of x equal k. For the square root of x minus 6 over x minus 1 is equal to 0. By letting it equal to k, it becomes a easier solution to work with. Okay. So what we have is k minus 6 over k minus 1 is equal to 0. So you see now the question becomes much easier equation to work with. So you multiply this by k. You get rid of the denominator, so k times k is k squared. Negative 6 over k times k is negative 6. Negative 1 times k is negative k equals 0. I write it in standard form, so x squared, k squared minus k minus 6 is equal to 0. So it becomes a trinomial now. So we've got k and k, 3 and 2. The bigger factor must be negative, so negative and positive. Okay, so k is equal to 3, or k is equal to negative 2. People at this point, very importantly, you cannot factorize, use the quadratic formula then. Okay? You're getting the quadratic, the roots now and then right. Then rather just use the quadratic formula. Okay? People, but what is k? K is the root of x. So we got the square root of x equal to 3. You get rid of the square root of square both sides. So x is equal to 9. On the other hand, you got the square root of x is equal to negative 2. But from a square root, you'll never get a negative. Not so. There's no solution on that side. Okay? And x can't be 0 there with regards to the restriction. Okay, but it didn't affect that. So, I wouldn't bother mentioning that there. .6 for 5 marks. This is your inequality question. You must get this in every major exam. Okay? It's going to be a minimum of 4 marks. So, what we do first is to get rid of the brackets. So we multiply in. I get x squared. I can either multiply it in, or I can divide by your negative first as well. If I divide by negative, what's going to happen? The inequality will swap around, not so. So I'm going to divide by negative. So it becomes negative 6 now. Inequality changes. And I'm multiplying it out here. So it's going to give me x squared. 5 times x is 5x minus 2x is going to give you plus 3x minus 10. Bring a 6 over, becomes x squared plus 3x minus 4 has to be less than 0. Trinomial. So we got x and x, 4 and 1. Plus and minus. So this is what we get critical values at this point. You don't say x is equal to negative 4 and 1. Again, you're going to lose a mark. You must say it's critical values because there's not solutions to the sum. And you can either use your sign line, your sign table, or you can use your girlfriend. On the side? That's right. Either you can use your sign line or your graph. I normally use the graph. So you got negative 4 and 1. So what we say, it must be less than 0. So it's below the line. Not so. This was decent phone. Does anybody have a number? Huh? Did you get the papers? Sorry? Doesn't have. No. Okay, before you leave, I'll make you a copy. If you want. If you don't want, it's fine. Sorry? Is a PDF fine? Or do you want a copy? Sorry? You want a copy? Okay, just before you leave, so remind me and I'll make you a copy. Okay. So, as you can see, it has to be less than 0, so it's below the line. Not so. Is that continuous or break-in solution? It is continuous. X has to be greater than negative 4, but less than 1. Okay. Next one. I probably have the papers in here somewhere if you don't have. Well, I gave it to my grade 11s of this year, which I doubt. They just like you people, no? And how are you? That stuff doesn't still bother you, no? Don't want to work and all those things. And when we go to the meetings, it looks like we as teachers are not doing our jobs. That doesn't bother you guys. But anyway, what do we do in 1.1.7? First thing is we isolate the root. Is the root isolated? Yes. The root is standing on its own. So what do I do now? Square both sides. So what do we get? X plus 5 is equal to first term squared, 4x squared. 2x times 2. 2x times 9 is 18x times 2 is 36x plus 81. So you take everything to one side. So 0 is equal to 4x squared. 36x minus x is positive 35x. 81 minus 5 is positive 17. 5 is 46. Okay. So again we use the quadratic equation, quadratic formula. which simply reads, you know, A is 4, C is 35, and C is 76, and B is 35. Okay, so if you've got this calculator, why not just use it? 76. The x values are negative 4. X is equal to negative 4, or x is equal to. Do we need to show the substitution into the quadratic formula at this point? No, we don't have to. Okay? The only point you need to show it is in question 1. Okay. People, is that the end of the story? No. What must we do? Check. And learners often don't check. Okay, it costs them a mark. So this is how we check. For the first one, x is negative 4. Whenever you see an x on the right hand side, it's negative 4. So negative 4 plus 5 is 1, the square root of 1 is 1. 2 multiplied by negative 4 is going to be negative 8 plus 9 is 1. So that one works. Okay, that's the solution. Let's now try the other one, which is negative 19 over 4. So you got the square root of negative 19 over 4 plus 5. It's going to give you a half. Okay? And 2 times negative 19 over 4 plus 9 will give you a negative half. Is a half the same as negative half? No. So what do we do? No solution. So you just put a line there. Okay? You guys understand? Very important question to get right. It's often asked in the final exam as well. The next one, in 2 point, okay, I think I need the space again. Simultaneous, definitely you must get the simultaneous equation, and otherwise it's not a maths paper 1. And yet the people still not getting this right. What they get over becomes negative 4. So wherever you see a y, you put a 2x minus 4. There's a y and there's a y. So you got 4x squared minus 3 into 2x minus 4 minus 2 into 2x minus 4 all squared equals negative 8. Okay? Which now gives us 4x squared minus 6x plus 12 minus 2 into your binomial squared, which is 4x squared. 2x times negative 4 is negative 8 times 2 is negative 16x plus 16 plus 8 is equal to 0. Go that over as well. Okay? So that's going to give you 4x squared. Okay? Before I make a mistake, I'd rather play it safe. Negative 4x, 8x squared plus 32x minus 32 plus 8 equals 0. So 4x squared minus 8x squared is negative 4x squared. Negative 6x plus 32x is positive 26x. 12 minus 32 is negative 20 plus 8 is negative 40. Is that correct? Sorry? 12 minus 32 is negative 20. Negative 12, you're absolutely correct. Alright, again you can use your quadratic formula, or you can divide by negative and find the factors. Or you can use what I got here. You got again negative 4. You got 26. And you got negative 12. So the x values is 6. Positive. Or x is equal to a half. But did I ask you to only solve for x? No. Let's calculate the corresponding y value as well. So y is equal to 2 times 6, which is 12 minus 4, is 8. Y is equal to 2 times a half, which is 1, minus 4 is negative 3. Quadratic equation, 7 marks in the bag. Okay. Let's carry on. Question 2. In question 2, they ask you, given a is equal to 4 to the n plus 2 times 9 to the n minus 1 over 72 to the n times 2 to the negative 2 to the 1 minus n. So of course, 4 4, 9, 2 and 72 can be broken up into products of its prime factors. So 4 can be written as, if we didn't know it was 2 squared, you say 4, but it's equal to shift and this button here, which is shift and factorize. As you can see, it's in yellow. To activate any yellow key, you press shift on the calculator. Otherwise, any maroon or red key, you press the alpha, which is next to that. Okay, so that is simply going to be 2 squared raised to the n plus 2 times 3 squared raised to the n minus 1 over 72, which is 2 squared times 3 squared, I think. 72 shifts factorize. Nope, that was wrong. 2 cubed is 8 times 9. So it's 2 and 3 squared raised to the n times 2 to the 1 minus n. Okay, so let's get rid of the brackets. So it's going to be 2 to the 2n plus 4 times 3 to the 2n minus 2. And this is all over 2 to the 3n times 3 to the 2n times 2 to the 1 minus n. Remember, when you multiply, your bases are the same, subtract the exponents. When we divide, no, with bases the same, when we divide and subtract the exponents. When you multiply, we add the exponents. So this exponent with those bases 2, only those exponents can be brought together. Okay? And then only these exponents here can be again brought together. Why? Because those bases are the same. Alright? So let's go back. So that will simply be 2 to the 2n plus 4 minus 3. And remember, when you bring it up, it becomes, the sign changes. Negative 1 plus n times 3 to the exponent 2n minus 2 minus 2. I think that's probably behind the calculator. Bring this over. Okay. So what do we do now? We add our items. So 2n minus 10 is negative n plus n. It's gone. 4 minus 1 is 3 times. That's gone 3 to the minus 2. So 2 cubed, what is 2 cubed? 8. Multiplied by, that is 1 over 3 squared, which is 1 over 9. So the answer is 8 over 9. Simplifies into 8 over 9. In the next part of the question in 2.1.2, it says hence or other. If it says hence, what does that mean? Now you get out of the windows and everybody's gone now. They live with us people now. No? Okay, so if it says hence, that means to say you must use your previous answer in solving the next part of the sum. So here we are told that A was equal to this here, which means to A is equal to 8 over 9, not so? So, if A is equal to 8 over 9, as we just showed there, also remember in the show that question, we can't use 8 over 9. We must end off with 8 over 9. You guys understand? So, that is going to be 8 over 9. And here they say hence or otherwise solve for x. If A is, what is A? Oh, I cut that 9 at the bottom out. So that is going to be A is 16 to the x over 9. Which now means to say, I can equate 8 over 9 equals 16x over 9. You see the nice part about this question is, if you didn't manage to solve the first part of the question, you can use that in your next calculation. That is why you better show that question. Okay, so that you can use that information in your next calculation. If you didn't get that answer, you understand? So, as you can see the bases, the denominators are the same, so we're not worried about it. So we're going to set the numerators equal to each other. So 8 is then equal to 16 to the x. But what can 8 be written as? 2 cubed and 16, 2 to the 4, not so? Raised to the x, which is 2 to the 4x. So therefore 4x is equal to 3, which implies that x is equal to 3 over 4. Okay. Any confusion there? No? 2.2. In 2.2 we are told to simplify. Okay? Simplify without use of calculator. What do you notice about that? And what is happening under the root? What do you notice? They're the conjugate pair, not some. Just like which will result in the difference of two squares. So you see both these square roots. So this can be written as the square root, which is 1 square root. Sorry. 2 root 5 minus 4 times 2 root 5 plus 4. Not so. So what can be done now? We can multiply the first and the last. That's going to be the square root of 2 root 5 times 2 root 5 is 4 root 5, which is 20, minus 16. 4 times negative 4 is 16, which is the square root of 4, which is? Okay. Can you believe the paper was so easy? You can't believe it. Okay. 2.3. In 2.3 we are told that if x plus y is greater than 0, what does that mean? If x plus y is greater than 0, that means to say it is going to be positive. That means to say it's going to be positive. And if x plus y all squared is equal to 3, determine without using a calculator, you must show that 18 over root 3 is equal to 6x plus 6y. So firstly we know that this we can apply the square root. So x plus y squared is equal to 3. If I introduce the square root, what must not forget? Plus minus. Can you see that? So x plus y is equal to plus minus 3. But what did they tell us about x plus y? It has to be positive. Yes, x plus y must be positive. So I say x plus y has to be equal to 3. Now coming back to show that question, on the left hand side, we got 18 over root 3. But we need to rationalize the denominator. Not so. How do we do that? By multiplying it by root 3 over root 3. Root 3 times root 3 is 3, and 18 root 3. 3 goes into 3 once, 3 goes into 18 6 times, so it's going to be 6 root. That's on the left hand side. If I can get the right hand side do the same thing, I've done the job. Not so. So now you go to the right hand side is equal to 6x plus 6y. So we take out 6 as a common factor. I'm left with x plus 1. You say, okay, hang on. X plus y is equal to what? The root of 3. Not so? Yeah, I've applied the root of 3. It's the right hand. So that's then going to be 6 times root 3, which is also equal to the left hand side. And there we just showed it. Can you see that? We now just showed that 18 over root 3 is equal to 6x plus 6y. Okay. Any questions here? Guys, this went quiet. Okay, we need to take this off here again. Are they? The sequence 2x plus 10, x plus 14, x plus 8 is linear. So what do we know about linear patterns? It has a first common difference, which means to say that T3 minus T2 equals T2 minus T1. It has a first common difference. Okay. So what do we have? X plus 8 minus x plus 14 equals x plus 14 minus 2x plus 10. Now it has become a matter of solving for x, which now gives me x plus 8 minus x minus 14 equals x plus 14 minus 2x minus 10. Bring everything to one side, x is one side, so that cancels. So it's going to be x minus 2x minus x. The numbers on the right hand side, left hand side, sorry. 8 minus 14 is negative 6. Negative 6 minus 14, negative 20, plus 10 is negative 10. Divide by negative both sides, therefore x is equal to 10. Okay. Then in 3.1.2 we are told that, and that now confirms this here. Not so. But say for argument's sake you got the 8 here, which is wrong. No? And they tell you if x is 10, then you can't use your 8. Even if you think you are right, you can't use your 8. You must use what is given here. Okay? So 3.1.2, so your positive mark you want to apply it. So if x equal to 10, determine the general term 10. So if x is 10, then it's going to be 2 times 10, which is 20, plus 10 is 30. 10 plus 14 is 24, and 10 plus 8 is 18. So there's my first 3 terms, in turn which I can then use to calculate my general term. Alright, so I do move from 1 to the next and subtract 6. The general formula is Tn is equal to a plus n minus 1t. Your a value of course is 30 plus n minus 1 times negative 6. So that's going to give you negative 6n plus 6 plus 30 is plus 36. There's my general term. And we can test it. Negative 6 times 3 plus 36. As we know, that term 3 of the sequence is 18. So if my answer is 18, then I've done the job. Okay. I never test on term 1 then. Okay, so that's 18. And you shouldn't also test on term 1. In question 3.2, in 3.2 we are told the sequence 41, 43, 47, 53, 61, 71, and so on has a constant second difference. So what does that mean? That means to say that your sequence or your general term will be quadratic. Quadratic has a second common difference. So the question says determine Tn. So how do I move from there to there? I'm adding 2, then 4, then 6, then 8, 10, 12, and so on. Okay. So that there is 2, 2, 2, 2. What do I write on the side? 2a, then 3a plus b, then a plus b plus c. From the bottom upward. Okay. The general term of course is Tn is equal to a n squared plus bn plus c. So how do I work out a? So in the how do we work out a? So it will be 2a is equal to 2. So a is equal to? So a is now 1, don't forget. No? So it's 3 times 1 plus b equals 2. So b works out to be negative 1. So there is 1, that is negative 1. Okay? So I now say 1 plus negative 1 plus c is equal to 41. Okay? That cancels. So c is equal to 41. Therefore, the general term is going to be Tn is equal to n squared minus n plus 41. Okay? And of course, it's worth testing again. As you can see, the sum is worth 4 marks. So wherever I see here n, I put a 4 or 3, whatever. I'm going to go with 4. The answer should be 1, 2, 3, 4. It should be 53. Of course, if it's not 53, then the answer is not correct. So 4 to the exponent 2. 4 to the exponent 2 minus 4 plus 41. And answer 53. So 100% correct. Then in the next question we are told that if the first 40 terms are prime numbers. So as you can see, all of these are prime numbers as it's shown here before, earlier. Are prime numbers. Show that the 41st term is not a prime number. Okay, so we're going to try and prove that. So let's go see what's happening at term 41. So it's going to be 41 squared. Wherever I see an n, I'm going to put the 41, which is there, minus 41 plus 41. So that cancels, not so. So term 41 is what? 41. But is this a 41 squared, sorry. So is this a prime number? No. What are the factors of 41? 41 squared. It's 1, 41, and 41 squared. Can you see that? What's a prime number? The prime number only has two factors. 1 and itself. Can you see that? What else is a factor here? 41. So since it has more than one factor, two factors, sorry, therefore it is not a prime number in conclusion. Okay, we just write that out. The next question. 3.3. They ask you to study the following pattern. Row 1 is 1, row 2 is 2, 3, 4, row 3 is 5, 6, 7, 8, 9, row 4 is 10, 11, 12, 13, 14, 15, and 16. How many terms are there in a row 100? Note row 4 has 7 terms, 7 numbers. Row 4 is 1, 2, 3, 4, 5, 6, 7. So the number of numbers in row 1, how many numbers are in row 1? 1. You see here they ask you how many numbers are there. How many numbers are there in row 2? 3. Row 3, 5. Row 4, 7. So they want to know in row 100. So from there to there I'm adding 2 all the time. Not so. So what's the general term here? Tn is equal to a plus n minus 1d. So my a value of course is going to be 1 plus n minus 1 times 2, which is 2n minus 1. So that's a general term. But they want to know the position 100. So term 100 or row 100 of course will be 2 times 100 minus 1, which is 199. So in a row 100 there is 199 numbers in that row. Okay, you guys understand? Then the question is asked in the next one. So plug this in. Then the question is asked with regards to calculate the middle number in the 75th row. So we don't actually need this. They want to know the middle number in the 75th row. So if you look here, what is the middle number here? It's 1. Here, 3. Here, 7. Here, 30. So those are the middle numbers, not so of row 1, row 2, row 3, row 4, and so on. So they want to know what number is in the middle of the 75th row. So we form another pattern. Sorry, we just did. Now we move from one term to the next. Adding 2, then 4, then 6. So how do I move from one term to the next? 2, then. So what type of pattern is this again? Again quadratic. So what do I write on the side here? 2a, then 3a plus b, then a plus b plus c. From the bottom up. Since it's quadratic, it's tn is equal to an squared plus bn plus c. So we know that 2a is equal to 2, 3a plus b is equal to 2, and a plus b plus c is equal to 1. So you're going to get 2a is equal to 2, so a is equal to 1. So there goes a 1 here. So it's 3 times 1 plus b is equal to 2. So b is negative 1. So you got 1, negative 1. Then we know that 1 plus negative 1 plus c is equal to 1. It cancels, so c is 1. So what's my general term? Tn is equal to n squared minus n plus 1. Let's test for the third term. So 7 squared is 49 minus 3 plus 1. No, minus 7. Nope, I made a mistake somewhere. The answer should be 7. Sorry, I'm starting 7 in mind. 3, I'm looking for term 3. 3 squared is 9 minus 3 is 6 plus 1 is 7. You see, and that term is 7. Which confirms that my general term is then indeed correct. But I have answered the question. What's the question? They want to know the 75th row. In other words, to us, the 75th number. Not so. So therefore, T75 is equal to 75 squared minus 75 plus 1. So you have 75 squared minus 75 plus 1. So they give you 5,551. Okay. Is that correct? Yeah. Let's carry on with our lives. 3.4. Question 3.4, we are told the following sequence is symbols. The following sequence of symbols is given. We got 1 alpha, 2 betas. So we got 1 alpha, 2 betas, 3 element signs. And then we start again. 1 alpha, 4 betas, is 1, 2, 3, 4, 5, 6 element signs. 1 theta, 1, 2, 3, 4 alphas. Nope. I didn't write theta. Theta is right at the back, it's 1. No? Then we had 2 alphas, 4 betas, 6 element signs, and 1 theta. No? Then we had 4. Then we had 4 alphas, 1, 2, 3, 4, 5, 6, 7, 8 betas, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, no, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 12 element signs in one. Can you see that, people? They want to know if the sequence is repeated, which means to say it's following this pattern, which symbol will appear in the 114th position? So the 114th position. So at this point, how many, what's the name do I have? I have 6, 7, I have 8, 12, 13, 14, I have 12, 6 is 18, 21, and I have 1, 2, 3, 3. So that is 21, is 42, is 45. At this point I'm standing at 45 characters, not some, or symbols. They're looking at 114. Okay, so remember, at this point I got 45. So I got 45. Okay, so it's 1, 2, what is? How many alphas are there going to be in the next one? How many alphas are there? 1, 2, 4, then must go 8. How many betas will there be in the next one? 16. You got 2 times 2 is 4, times 2 is 8, and 8 times 16. How many element signs will there be? 3, 6, 12. What's the next one going to be? How do I move from 3 to 6? Times 2. Then times 2. So it must be 24. And how many theta signs will there be? 1. If I extend this further, then of course it's going to give you 16. Times 2 is 32. Times 2 is 48. And 1. Can you see that, people? So now let's put it together. We're looking at 114. So if I add 8 to this, I'm going to get 53 plus 16. Okay, accounted for that plus 16 is going to give you 69. Then 24. It's going to give you 3, carry 1. And that's 7, 8. No, 8, 9. Plus 1 is 94. Okay, you all okay with that? So I'm standing at 94 now plus that 1. Okay, so that's 94. Plus 16 is going to give you 10, carry 1. So it's 110. Then plus 32 is going to be 142. So that means to say, from 111 to 142 to the 142nd character, it will be Peter's involved. So therefore, the 114th term or character, whatever, will be Peter. Okay. This doesn't conform to your normal understanding of patterns. You're just thinking this is your problem solving question. Okay. It was a nice question. I think there was a few that got this right. Did any of you guys get it right? Okay. So we're moving on with our lives. Question 4. In question 4 we are told that what is the original price of a car if it was worth 160? So it was worth 160. No. What was the original price? So we're going to calculate P here. If the car, if it's worth 165,000 after 6 years and depreciates on reducing balance method. So A is equal to P into 1 minus I to the exponent n. So A is 165,000 into P equal into 1 minus, we are told the reducing balance method at the rate of 9,5, so 0,095 to the exponent 6. To get P on its own, I'm going to say 165,000 over 1 minus 0,095 to the exponent 6. Okay, that is fairly simple. 165,000 over 1 minus 0,095 to the exponent 6. The original price of the car was worth 30,000, 325,68. That was the original price of the car. Okay? Don't forget the reducing balance method formula is applied there. The next one, 4.2. So Z is offered an interest rate of 13% per annum compounded quarterly. 13% per annum compounded quarterly. So there's 1 over 4 there. Okay? By a bank, calculate the effective annual interest rate. So that formula is 1 plus I effective. This formula is not given in the exam. Okay? 1 plus I to the m over m to the m. Again, this m has no bearing on that I. It is just to show that that I to the m is a different I effective. Okay? But it has no actual bearing on the calculation. So again, it's offered an interest rate of 13% per annum compounded quarterly. This is a nominal interest rate. They want you to work out the effective annual interest rate. So it's 1 plus I effective, that is what we're calculating, the effective interest rate, equals 1 plus I to the m, which is 0,13, over this quarterly to the exponent 4. So what I do is I take that over. Remember they want a rate, so I multiply it by 100 thereafter. Okay, so it's going to be 1 plus 0,13 over 4 to the exponent 4. Get an answer, then minus 1. Gives you 0,13.6. However, they want a rate, so what must I do with this? Multiply it by 100. Okay, which gives us 13,65%. Okay, so that's that. The next one, we told that Joseph is saving for his son's first year university. He deposits 8,000 rand and then adds another 10,000 38 months later. Huh? Definitely timeline question here. Saving for his son's first year university. He deposits 8,000, that's T0, and 38 months later. How many years is that? So you say 38 divided by 12 gives us 3 years and 2 over 12. This was 1 over 6. No, it's 2 over 12. Alright. How much will he have in his account at the end of 5 years? If the interest is calculated at 7.5% per annum compounded monthly for the first 3 years. The first 3 years, the interest rate is 7.5% per annum compounded monthly. Then it increased to a daily interest rate of 8% per annum. Daily, so it's 1 over 360. And there we go. Okay, so what happens? Oh yeah, this must be plus 10k. 10,000 is depositing. So there's many ways of doing this. What I do is I consider the 8,000 rand till the end, and the effect that the 10,000 rand has until the end. I find that to be the easiest method to apply, but as I said, there's other ways of doing it. Others find other methods more easy. Okay, so let's do this. So I'm considering the 8,000. So we say 8 total, going to be 8,000. That 8,000 is going to go all the way to, no, I don't know why this had to happen now. Okay, so you're going to consider 8,000 rand till this point. Why? Because at that point the interest rate changes. Can you see that? So 8,000 into 1 plus, that is going to be 0,075, because that's a percentage, so I divide by 100 over 12 to the exponent 12 times. And for how many years is this for? 3 years. Then what happens to it? It throws an interest again for the remaining time span of 2 years. Not so. Okay, it looks like the timeline is not drawn to scale. Of course it's not. So this 3 looks much smaller than 2, no? But don't worry about that. Just to give us a graphical representation of actually what's happening here. We have an idea of what's happening, not about. So what's your interest rate in? 0,08 compounded daily, so it's 365. So the 365 for how many years? 2 years. So they have considered that 8,000 rand. So let's consider the 10,000. And to taking that to the end is just basically one calculation. Can you see that? So what happens? They're adding 10,000. If Joseph had to take out 10,000, I would have said it minus 10,000. Then I would have made it minus 10. Not so. So if you take that into account, it's going to be plus 10,000. So it's 10, 1, 2, 3 into 1 plus 0,08 over 365 to the exponent 365 times. And how many years is it from 3 and 1 over 6 or 3 and 2 over 6 to 5 years? You can just say 5 minus that answer gives me an answer of 1 and 5 over 6 or 1 and 10 over 12. In terms of years, I can just write there 1 and 10 over 12. Okay, you guys understand? So then your A total value, A total of course, is then equal to, you put this in the calculator now. Okay, so it's going to be 8,000 into 1 plus 0,075 over 12 to the exponent 12 times 3 times 1 plus 0,08. Somebody just check the answer there. 365 to the exponent 365 times 2 plus 10,000 into 1 plus 0,08 over 365 to the exponent 365 times that last answer calculated. Give me an answer of 23,327 rand. Is that correct? 23,327 rand and 97 cents. Okay. It's a nice question there. As I said, there's many ways that that particular sum could have been answered. Okay. Let's look at 4.4. We are told that Tatum invests X rand into a fixed deposit. Again, timeline. Okay? T0 is X rand into a saving, into a fixed deposit which pays an interest rate of 10% compounded monthly. That's a straight interest rate there of 10% per annum compounded monthly. Okay. After 3 years, she withdraws half of the money. So T3, half of what money? After 3 years, she withdraws half of the money in the account at the time. So withdraws half year minus half of whatever A is at that point. You understand? Okay? She leaves in the account at the time. She leaves the remaining money in the account for a further 2 years. It takes her to T5. At which there is 15,000 rand in the account. So she ends up with 15,000. You guys understand? The question is how much was put into the account. Okay. So from here, firstly, let's consider the X. What's happening here? It's X into, we need to take it till this point here. Not so. So it's X into 1 plus 0, what is this? 10%, eh? 0,1 over 12 to the exponent 12 times 3. So that is what's going to happen to X over 3 years. But what happens to it at that T3? You must divide it by 2. Can you see that, people? Then what happens to that answer? It's going to draw an interest again for how many years? For how many years? 2 years. So it's going to be 1 plus 0,1 over 12, the exponent 12 times 2. Once this calculation is made, it gives you how much is left in the account, not so? And in this case, how much is left in the account? 15,000. People, you guys understand? Who doesn't understand? Okay. So from here, it's a matter of solving the equation. Firstly, I divide both, get rid of the 2, divide that side, so it's going to be x into 1 plus 0 comma 1 over 12 to the exponent 36 into 1 plus 0 comma 1 over 12 to the exponent 24 equals 30,000. To get x on its own, I divide both sides by whatever that works out to be. So x is equal to, it's going to be 30,000 over, open brackets, 1 plus 0 comma 1 plus 0, 30,000 into 1 plus 0 comma 0 1, 0 comma 1 over 12 to the exponent. When you multiply and base the same, I can add my exponent. Looks like it's 60. Let us check if that is correct. Nope, must be over. 18,223 and 60. Correct? Huh? What is a yes? Did you check? Okay. So 18,233 rand and 60. It's a nice question, huh? What do you think? It's not one of the normal questions that you're exposed to. Okay, something to think about again. Yes?
How much is the investigation?
You'll be out of 50 marks, 400. You're going to write in your maths period. Okay, so here we are told that in question 5, f of x equals 2x squared minus 6x minus 20. Okay, so that's your f of x. Okay, so f of x equals 2x squared minus 6x minus 20. And g of x is equal to mx plus k. CF is parallel to the y-axis, and CF is 12. It is 12, whoever we took this paper from has written it in already. Okay. Let's look at the first question. First question says, write down f in the form of. So this is basically to complete the square, not so. So we make it a bit smaller. Okay, let's put every question here at the bottom. If we can keep our diagram in focus. So yeah, what I need to do is I need to complete the square. So it's f of x is equal to 2x squared minus 6x minus 20. But take up 2 as a common factor, I'm left with x squared minus 3x minus 10. So of course you must add a number to complete the square with minus that same number. In this case the number is 3 times a half is 3 over 2. Squared is 9 over 4. So there's your perfect square trinomial. That's going to give you 2 into x minus 3 over 2 all squared minus 49 over 4. Of course we get rid of the 2, so it's 2 into rid of the block brackets, it's 2 into x minus 3 over 2 squared minus 49 over 2. Okay, is that correct? Okay. Let's go to the next question. The next question says determine the coordinates of A. So what is A? A is my x-intercept. Not so. So how do you calculate your x-intercept? You said y equal to 0. Not so? So we say 0 is equal to 2x squared minus 6x minus 20. I can either use the quadratic formula or I can divide by 2 and then use the rules of factorization, or I can use this calculator here. It's going to be 2, negative 6 and negative 20. It's going to be 5. You see how much time this calculator actually can help, can save us? And negative 2. Okay. Did we answer the question? No, what's the question? Coordinates of A. So therefore, A is going to be negative 2 and 0. Of course, that is where 5 is going to be. Okay, which is your other x-intercept. The next question says the coordinates of C. You want to know what's the coordinates of C? And where is C here? But C is also the point of intersection of your straight line and your parabola. But I don't have the equation of the straight line at this point. Not so. I don't have the equation of the straight line at that point. So what do? We also know that that is given, if C is given as a length of 12. So which means to say at this point here, C is already some x value and 12. Negative 12, so why negative 12? Because on the negative part of your y-axis. Not so. You take this off here. That's why I was writing the information on the side here. So I can keep my diagram in focus. So it's 513. So it's going to be, so you're going to substitute C, which is x and negative 12, into f of x. Why in f of x? Because I got the equation of f of x at that point. You guys understand? I don't have g of x. So again, that's an x and a y. So negative 12 is equal to 2x squared minus 6x minus 20. Take it over. 0 is equal to 2x squared minus 6x minus 8. Again, either divide by 2 or use a quadratic formula. Okay? So it's going to be 2, 2, negative 6, and negative 8. So they give you 4. So x equal to 4. 4x is equal to some y value of negative 1. But which one is it? Definitely it's going to give you an answer of 4. So therefore C is going to be 4 and negative 12. But just looking here, if you take this into account from there to there, let's say this is 12. Okay, it's given 12. But if you take this here, this line I just drew here, this blue line, somewhere along here will also give me a value of negative 12. Can you see that, people? And does it look like it's about at minus 1? Can you see it, people? It's approximately minus 1 anyway. Okay? So, the C value is 4 and negative 12. Also, that if C is on the positive part of the x-axis, that's why I went to it positively. Okay, we've got 4 minutes left. We'll just wrap this up. Okay? Did C now, no? 5.1.4. Then determine M and K. Now M and K is coming from G of X. Okay? So 5. No? Don't know why this thing does this. Okay, so we look at g of x coming from that formula, and these are 2 points that's lying on that straight line as well. Okay, so in 514, it's simply going to be the gradient, which is the change in y, the change in x. That's negative 2 and 0, and C is 4 and negative 12. So it's going to be negative 12 minus 0 over 4 minus 2, which gives me 2, a gradient of negative 2. Okay, as I saw the graph is lying to the left, so it must be a negative gradient. So you got y is equal to negative 2x plus c. To calculate c, I must substitute the point that's lying on this graph, which is negative 2 and 0. Again, that's a x and a y. So 0 is equal to negative 2 into negative 2 plus c. That's negative 4. And positive 4, you take it over, it becomes negative 4. So y is equal to negative 2x minus 4. Does it make sense? Yes, because there is your negative 4. Okay. Negative 2x minus 4. Okay. Then the next question. That one, 5.2 we'll wrap up next week, and that is sort of the paper. So, okay. So then, just 515, where's f of x? 5. You guys leaving? Okay, so we'll just carry on from here next week. Okay. Yes? Yeah, I'm going to print it now. Just have a look at what she has. So the wrong thing I said. We'll stop here, okay? Yes. Check.